Hey guys, in this video we're going to have a look at one of the three ways that you can represent chemical reactions, and this is called the structural equation. So chemical reactions can be represented in terms of the graphical structures, I suppose, of chemical substances. So with structural equations, you should really understand that chemical substances are represented graphically. Okay, so chemical substances, so the reactants or the products, are represented graphically. So you draw them. That's what it means by graphically. So let's just use this this water splitting into hydrogen and hydrogen and oxygen example. So if you watch the other two videos for the other chemical equations, so the word equations, the symbol equations, you would have seen that water splits into hydrogen and oxygen. And you need two water molecules splitting into two hydrogen molecules and one oxygen molecule. Alright, so if you're wondering where these big numbers in front of the molecules, the formulae are coming from, these big coefficients, have a look at the symbol equations video. Alright, now it's probably, with writing structural equations, it's always best to start off with the symbol equation. You want to establish the symbol equation, and that way you can draw out the right number of each of the chemical substances involved. So with this reaction, we have two water molecules. So we're going to draw out two water molecules, okay? We know that we need two water molecules in order for this reaction to really be all balanced out. Now these water molecules, they split. So under certain conditions, like a lot of electricity being applied, water will split. We break apart. We get two hydrogen molecules from that. So we draw two hydrogen molecules. So you can see here that I've drawn a hydrogen, like these little atoms here are hydrogen. And so these big red guys, big red atoms are oxygen. So we have two hydrogen molecules here being formed. We have a plus sign, as always, to separate the two different products. And then we have an oxygen molecule being formed. So just to show you how this is balanced, you can track every atom on the reactants into the product. So what do I mean by that? So let's shade in this oxygen atom here. This oxygen atom breaks apart with those hydrogen atoms that it's attached to in that water molecule, covalently bonded to in that water molecule, and then it rearranges itself. So it's probably found over here. This other oxygen atom breaks apart from its hydrogen atoms and then finds itself here bonded to the oxygen atom. And you can track every single atom. And it's really important that you understand that chemical reactions are all about all of these different atoms just finding like new partners and stuff, forming new bonds. All right. Chemical reactions involve the breaking of bonds, I should say bonds in the reactants, and the forming of new bonds in the products. So with this water splitting reaction, these water molecules here, these oxygen atoms are covalently bonded to hydrogen atoms, and these bonds are broken up. And those hydrogen atoms, they with those broken bonds, they reform new bonds with other hydrogen atoms, as you can see here. And those oxygen atoms with their broken bonds reform new bonds with each other. The oxygen atoms find each other. And this is why chemical reactions really need to be balanced. So if you have atoms coming in on the left and they break bonds, they will have to appear on the right with new bonds. Okay, they have to appear on the right having formed new bonds with different atoms. So one more example for this video. Let's just go with the methane and oxygen combusting reaction. And the balanced equation, I believe, looked like this. Yes, that's balanced. So that's how I'm going to drawing this out. So carbon's like that. Let's draw little hydrogen atoms around this carbon. Not really technically correct. It should be more like 3D into a tetrahedral shape. And oxygen. How many oxygens do we have? Well, we have the plus sign here. We have 3. So how many oxygen molecules do we have? We have 3 oxygen molecules. And each of these oxygen molecules is going to find itself in the product somewhere. Okay, so that one carbon atom on the left finds itself now in a carbon dioxide molecule. Right there. Carbon dioxide. I think I made a bit of a mistake by drawing oxygen as being larger than carbon. Don't think that's technically true. But you'll just have to go with that. Forgive me about that. If you look at the atomic radii of carbon and oxygen, carbon's bigger. So it's one of the trends that as you go to the right along a period, atomic radii decrease. Anyway, we have 2 water molecules. So here are the oxygen atoms here. And we have these hydrogen atoms there. Okay, so if you have a look at this overall structural equation that we've drawn, you can track every single molecule and find where it ends up in the products. So this oxygen, let's say, goes there. This oxygen, say, goes there. And this oxygen, say, goes there. Whoops, I made a bit of a mistake. There should be only two oxygen molecules here. So if we were to track every oxygen molecule, it appears there. So you see that every oxygen molecule, you track the carbon atom here, ends up there, and each hydrogen atom, so if you were to follow it, each hydrogen atom here, you'll find there, just appearing on the other side somewhere, or appears in the water molecules, if you're going to be specific. Each hydrogen atom finds itself on the right. So each hydrogen atom has rearranged, or every atom really has rearranged itself, broken its old bonds and formed new partners. Alright, so in this video we've had a look at structural equations, one of the 3 ways that you can represent chemical reactions. And in this video we've really explored why it's important that chemical reactions have to be balanced, because whatever comes into the reaction in the reactants has to come out in the products. We can really see that new bonds are formed between atoms. So atoms are finding new ways to connect with each other. That's the whole principle behind new bonds being formed. Alright guys, thanks for watching.